In this video I'm going to look at cubic functions. Let's just have a quick recap of what functions are. You can get different types of functions. You have an input, usually our x value, and we have an output, which is our y value. I've just drawn a rough sketch of some Cartesian planes, x and y plane. If I've got a straight line like that, that's just the equation of a line. The highest power of x will be 1. If I have a curve that goes like that, that's a parabola shape. That's a quadratic equation where the coefficient of x squared is positive. If the coefficient of x squared was negative, it would look like this. So for the quadratic there, the highest power of x is x squared. Now for the last one, which is the cubic, it goes like that. So here the highest power of x will be 3, and it will be positive if it goes like that, and if it's a negative coefficient of x, it will go something like that. So to solve cubic functions, we first need to look at something called a factor theorem, which states that if f of k is equal to 0, so that means when I have a function, I plug in the number k into that, and the resulting value is 0, then I can say that x minus k is a factor. Likewise, if x minus k is a factor, then f of k is equal to 0. What we need to do to solve cubic equations or cubic functions is we need to find a first root using trial and error, and then we use some long division or alternative methods to find the second and third root, if a second and third root exist. Okay, so we're going to look at a leaving cert question here. This came up in 2015. So, if f of x goes to x cubed minus 3x squared minus 9x plus 11, we're asked to find the three roots of the equation. That is, the 3 points where the curve touches the x-axis. As I've written here, the first root is always found by trial and error using the factors of the constant here. So factors of plus 11. So effectively what we do is we plug in the factors of plus 11 in for x. So we substitute it in until we get a result equal to 0. If we get a result equal to 0, so let's say f of 1 equals 0, then x minus 1 is equal to a factor. And we can find the other factors using long division. So if I plug in 1 to start with anyway, f of 1, I get 1 cubed minus 3 times 1 squared minus 9 times 1 plus 11, which actually does equal to 0. Therefore, 1 is a root, so I know my curve touches the x-axis at x equal to 1, and so x minus 1 is a factor. We then carry out some long division. There are other methods to do this, as I said. You use the box method to factorize, but here we're just going to use long division just to recap it. X minus 1 divided into x cubed minus 3x squared minus 9x plus 11. Okay, so first thing we do is we divide the x into x cubed. X into x cubed gives me a result of x squared here. What I then do is multiply x squared times x and multiply x squared by minus 1 and write the result here. So x into x cubed using this green line gives me x squared. X squared times x gives me x cubed. X squared times minus 1 gives me minus x squared. What we then do, because we're going to be subtracting that line from the one above it, it's easier, algebraically at least, rather than subtracting this highlighted green version from the one above, it's easier just to change the signs in front of both and add them together. You don't have to do that, but it's just an easier way of doing it. So we change the signs and add, so this now becomes minus x cubed, add that to the one above and we get 0. This now becomes plus x squared, add that to minus 3x squared and we're left with a result of minus 2x squared. And we then bring down the minus 9x. So we're now left with this. My next step involves repeating the process of step 1. So I divide x into minus 2x squared. So that essentially means, what do I need to multiply by x to give me minus 2x squared? Well, I need to multiply it by minus 2x there. And then what I do again, the same as what I did at the start, I take my minus 2x and I multiply it by both of these things and rewrite them in the line underneath. That then gives me minus 2x squared plus 2x. I change the signs and I add, so just that's going to be a minus. So I've got a plus 2x squared minus 2x squared gives me 0. I've got minus 2x and minus 9x, which is minus 11x, and then I bring down the last constant there, and I repeat the process a third time. So x into minus 11x gives me minus 11. Minus 11 times x and times minus 1 gives me minus 11x plus 11. When I add those two together, I get 0, so I've got no remainder. So x minus 1 divides evenly into this cubic, with the result being x squared minus 2x minus 11. And we're left with this. Remember to simplify surds. When we've got any surd a, b, that's equal to root a times root b. So what we effectively can do is factorize that 48. One of the factors is perfect square. In this case it's 16. So root 48 is equal to root 16 times root 3. Well, root 16 is just 4. So root 48 is equal to 4 times root 3. Then we're able to divide everything by 2, and we're left with x is equal to 1 plus or minus 2 root 3, and x is equal to minus 1. We can always check our results, which is what I've done here. The sum of the roots is always equal to minus b over a, so when we go back to our cubic equation here, at the very start, the sum of our roots should be equal to, where this is a, this is b, this is c, and this is d, minus b over a. So the sum of our roots will be equal to minus 3, which is 3, over 1. So the sum of our roots should be equal to 3, which is what we get here. You don't always have to do this at all, but those kind of tricks are useful, especially for complex numbers questions that come up later.